everyone, and welcome to our Lunch and Learn webinar series. My name is Allison Lacacha, and I'm the Marketing Manager at TeshCon USA. I'm honored to have Albin Baranauskas, Managing Director of TeshCon GmbH, here with us today to present SpectroDens up close and in depth. Please use the questions pane in the GoToWebinar panel to type in all of your questions. We will be addressing them at the end of the webinar. We do hope everyone is safe and healthy during these challenging times, and we hope you enjoyed the presentation. And I'll hand it over to Albin.
Thank you very much, Alison, for the introduction, and hello to everyone joining us today for our webinar. I hope you all are doing well and you are safe and healthy in these extraordinary days. In the time of lockdown, many webinars are offered, and we are happy you decided for ours today to get some depths in details about our SpectroDens instrument. So, my name is Albin Baranauskas, and I'm Managing Director of TeshCon Germany. We are on the market since more than 35 years. Our focus is developing and manufacturing innovative and high-quality measuring instruments for the printing industry. I am with TeshCon now since more than 25 years, and you may not believe it, but I still work with joy and passion with our TeshCon team and our partners for our customers. I have prepared some slides now. Don't worry, it's just 8. But before we get to the live demo part, I would like to highlight some general aspects about the requirements for spectrophotometer. And these points are important for us as a manufacturer, but I'm sure also for our customers. So if we start talking about the requirements to a spectrophotometer, there are some points everybody should take care about, and I would like to point out some of them. They are for sure the conformity with the ISO standards. That means not just supporting ISO standards for the printing industry, but also the ISO standards for the manufacture of instruments, because there are also some regulations we have to follow in order to are in compliance with these standards. Then for sure, it's about the accuracy. The instrument should be as accurate as possible. It shall be reliable in the press room. It should be, yes, like a Swiss knife, like a Swiss Army knife, high versatility. It should be easy of use because nobody likes to read manuals, also for me. And the inter-instrument agreement is a big matter, a big issue today, because very often we have several locations, we are printing same jobs, and we want to make sure that all the color is at all locations the same values. If you have a look about the accuracy, then the most important point is the resolution of the color sensor that is used inside the instrument. And based on the ISO standards, the spectrophotometers today should have or shall have a resolution of 10 nanometers. In the past, there have been instruments on the market with a lower resolution, some filter stack instruments, some filter wheels instruments, but the highest resolution normally have instruments with a grating. As you can see on the right side of the picture, there's a slit and a grating and photodiode array with a high resolution. And today we are using an internal resolution of pixel distance of 3.3 nanometers. So that means a really high resolution to get a very smooth and accurate remission curve, as you can see in the center of the screen right now. And you also can see what happens if the resolution is lower, then the curve is not as smooth and you cannot detect peaks or certain steep slopes of curves, which leads into less accurate values. Then for sure, reliability is a big issue. So today, all instruments on the market are equipped with mostly with LED technology. Some still have a combination of tungsten lamps and LED. We preferred to use LED technology only because it has a very low power consumption and it has a very long lifetime. So we expect that we never have to change the illumination of our instruments because of that long lifetime. which also leads to less service cases. Then the battery is one point. The instrument should do as much as possible measurements, and 10,000 today is no problem. But the lifetime of the battery is a new aspect as well, because it's a wear and tear part battery. Normally, standard batteries have 400 to 500 charging cycles, but today we are using technology that allows up to 4,000 charging cycles. That means, again, we don't have to replace the battery during the lifetime of the instrument, which also, again, leads to less service cases. And finally, we're constructing our instruments in a way that we get rid of wear and tear parts. If we have a look on the charging technology we are using today, in the past that have been charging contacts. So these charging contacts had to be replaced after some years because they get worn and have to be replaced. Today we are using inductive charging technology. No more parts, no more contacts, and for sure less service cases in this case as well. And we know in the environment of a press room, it's a quite harsh environment. So press operators never have time, they are in a hurry, and so an instrument can easily drop down to the desk or even to the bottom, and it should not be damaged or should not be broken immediately. It's very important that these instruments are robust and reliable. By designing the instrument, we try to avoid also any kind of moving parts, because moving parts are stress parts and wear and tear parts. That means these are the weak points of every instrument, and therefore we are not following the clamshell technology where we have to lift up and down instruments. We have a fixed system. Nothing is moving inside the measuring head during the measurement. And sometimes you can see instruments on the market, you can feel the vibration, there's something moving inside. So we try to avoid that because it makes the instrument more reliable over time. Finally, we have the versatility. The instrument should do, if possible, everything. For sure, today instruments are combined devices, densitometer and spectrophotometers in one device. That means we can do all densitometric analysis and also the CLAB, delta E, all colorimetric information we can get out of these instruments. More important, having two instruments in one, is the integrated scan technology. That means measurements taking time, and as we know, press operators don't have time, so measurements should be done fast and easily. So scan technology is a must because you can save a lot of time with that technology. And the best would be if it's integrated without any extra parts. So one instrument that can do both scan and spot measurements. And we have different needs also for the patch sizes. Sometimes in packaging printing, there is not a lot of space on the sheet, so the patches shall be as small as possible. And therefore, different apertures are available. Mostly you can use all instruments on the market with different aperture sizes, but it would be good if you can replace the aperture by yourself, depending on your needs. So because it's also a fact that the aperture should be as large as possible and only as small as necessary. If you are using a small aperture, then there are some limitations. I tried to describe it on the right side. So if you have a coarse screening and you have a small aperture, then it can happen that you can have less dots depending on the positioning of the measuring head. So having a small aperture, you should take care about the accuracy and repeatability of your measurements. It can be compensated by doing a scan measurement, because then we do 500 measurements per second during a scan so that you get an average value. But generally, it is better to use a large aperture if possible and a small one only if necessary. And therefore, it's nice to have if you can exchange the aperture depending on your needs by yourself. Data transmission is also something we need today because we are using software for analyzing, for reporting. So it's important to get the values to the computer, and this should be done via cable as usual, or maybe if possible wireless. Wireless data transmission is it's nice because you can transfer values via the internet, via the network internally in the company. Sometimes it's a problem because it's not allowed, and we still have the cable data transmission available. Ease of use, it's one of the most important aspects during development. So the instrument should be self-explaining. As I mentioned before, nobody is reading the manual, so it would be good if it is intuitive and you know exactly what to do if you look for function or some settings. And we try to develop our instruments in that way. And we did some tests with some children, and I mean, for them it's easy because they can use mobile phones like nothing. And so they also can use these kind of instruments within a few minutes. They know every settings, every points, and so we think it's quite easy to use. But the information displayed should not only give the values, so it's good to have some help from the instrument as an operator. So the instrument should also show is the value within tolerance range or not? And if it's out of tolerance range, what to do to get better? So some recommendations integrated in the functions are very helpful and also save a lot of time during the use. Automatic settings and automatic functions also prevent user errors. So I will show later when we use the instrument, selecting the right M conditions, for example, or selecting the right delta E, depending on the ISO standard or other standard you are using, is quite important. And so that is helpful automation within the device as well. So inter-instrument agreement, that means different instruments from one brand or even from other brands. If you compare values, the values should be equal, or let's say very close to each other, in order to have no discussions about different instruments. And I would say today, with the latest technology we are using, with the ISO standards and the M conditions, we have seen in many tests that today high quality instruments are very close to each other. So it's no problem to compare two brands to each other and get the similar values. As you can see in my examples on the lower side, I have measured with two instruments, brand A and B, and compared the values of a single patch, and we are in a delta E of maybe 0.1 or 2. So it's not a big difference. Then it's important the traceability about the calibration standards. It has to be a certified institute, and also this is more or less a global standard. And NIST in the US is certifying the primary standards all the color measuring instruments manufacturers are using internally, and this material that is used for checking and calibrating the instruments is ceramic tile, so it's very stable and a good material which is reliable as well. If we talk about instrument calibration, then we differ between two types of calibrations. First of all, the internal calibration, that is what the customer can do. Means this is a typical paper density calibration for density measurements. And if you do LAB readings, you do an absolute white standard calibration. And that should be done for every new job, or if you don't know who has used the instrument before, just to make sure the instrument is properly calibrated. The instruments usually provide the information when it has been calibrated last time, so this information is available, and so you can check if the instrument is in a proper condition or not. And then we have the external calibration. This is what we call full spectral calibration of the optics and the color sensor at the manufacturer side. And this is something we recommend to do every 2 years. So it is a long time, 2 years, but because of the construction and design we have done in the development of our instruments, the instruments are quite reliable, and we can guarantee that for 2 years the values are stable. So this should be taken also into consideration, because it is not just, let's say, the investment of an instrument if you purchase such a spectrophotometer, but also the service cost, which adds over the years. And some manufacturers ask for calibration every year, but we do every 2 years only. So I think also it's a nice advantage about our technology. So conformity with ISO standards, I think that's the last point of my slides. It is for sure good if the instrument can provide all the standards that are available. Sometimes I still have these difficulties to really look through that different standards. The German part or the European part, PSO, FOCRA, PSD, ECI. Then we have ID Alliance with G7, Krakow, SWAP. And then we have the ISO with the Technical Committee 130 for the printing industry, with the ISO standard 12647, the ICC consortium. So there are a lot of target values, references, and tolerances. And today, a good instrument should support all these standards, and they should be integrated in the instrument to make it easier for the user. I will do a live demonstration now with some of the functions we have implemented, and to demonstrate how easy it is today to use a spectrophotometer. What are the values that such an instrument is providing, and how to operate it in a little bit in a way. And I'm happy to answer any questions you may have after this demonstration. So please collect your questions, and you can send it then to Alison. And after that, I'm happy to answer you. So for getting to the demonstration, I am using a software called SpectroConnect. That is the software we are using to show the display of the instrument. But before I go to the details of the functionality of the device, I'll just turn on my video. I hope you can see it. And I would like to tell a little bit about design and construction. So this is the SpectroDens I'm talking about today. It's a quite robust instrument. It's a solid aluminum casing milled out of one block. You can see the aperture here. This is the point where we take the reading. And the nice feature here is that our construction is like this, that you can always see where the instrument is positioned. So the patch is not covered by the instrument like with other instruments. So you always can see where you are scanning. And for scanning, we have these integrated wheels on the bottom and the front side. It makes straightforward scan possible, so it's running straight forward. It is allowing a safe positioning on the patch. So as I told you before, we have the option to change the aperture. So this is the aperture part. So in case you need a smaller aperture, you just take a screwdriver. We have a very nice tool here. It's our TechCon pen. It's a universal tool like our instrument. So it is a level, and it also has a screwdriver integrated. So you just open the 2 screws, and you replace the aperture to 1.5 millimeter light spot for 3 millimeter apertures, and then you can do measurements on small patches. The instrument is equipped with the USB connection for data transmission to the PC, and I also mentioned before it's possible to put a Wi-Fi card inside. It also can be retrofitted. That's our Wi-Fi card. You can open the casing, you just put it in the slot, and then you can do Wi-Fi data transmission. Together with the instrument, we have the charging console, and here that is inductive charging, no charging contacts. That means I place it here and the battery will be charged. And by the way, if I connect it to the PC via the USB cable, it also will be charged. You can see it on the icon on the display. So some people have asked, the white standard is not covered, it's not protected. Some say that may be a disadvantage. I always say it's an advantage because I can see the condition of the white standard. There are instruments on the market with integrated white standards, but I have experienced that it can be a problem because printing powder and paper dust gets everywhere, even in protected white standards. And so in our case, it's quite easy to take a towel. I use that for my glasses and clean it to make sure it's okay. And then I place it here and I do a calibration. So this is about the white standard inductive charging. And now getting to the instrument and how to use the device. I have my demo sheet here. That's a printed sheet, offset print. We put it in the case of every instrument, and it helps a lot to play around with the device after receiving it and to learn a little bit how it's used in the best way. And I'm using that now to do some demonstrations. Unfortunately, the instrument is turned on already because I wanted to show you how fast the instrument is working. So it has a start time of 1 second. That means if I take off the instrument right now, it goes to a sleep mode after 1 minute. And if I press the button, it is turned on immediately. So maybe it's not a big aspect, but sometimes I have seen instruments that take 20 seconds to turn on. So again, press operators don't have time, so they don't want to wait for the instruments. Okay, connecting it again. The best feature on that instrument, in my opinion, is the scanning function. I still like it so much. It's just a cool invention. So scanning without any extras directly with the instrument makes a lot of fun. And I would like to show you some functions now we are supporting with the scan. And therefore, I explained a little bit about the buttons. These are the control buttons, and you can see we are going around in the display to different points. So here on the lower left side, we select the functions. On the lower right side, we have the settings. And here some parameters like calibration, delta mode, and the settings of the device. So let's go to a function like print curve. So we surely can do all the densimetric measurements like dot percentage, TVI, and stuff like that. But print curve is something which is quite unique, and it's a great function. So in the display, you can see what you should do. Just measure a step wedge 10%. You can define it yourself for sure. And start at the 100%, stop at the paper. And let's have a look what will be the result. So therefore, I just using a step wedge. And by the way, this step wedge has contrast lines because in the older generation of instruments, it was necessary to have these contrast lines. But today, we even could measure without them because the encoder inside the instrument with the high sampling rate of 500 samples per second makes it possible. I press the button, I scan, and I get the result. So in the result, I can see I have used a TVI display. So that means I can see the ISO standard 2013 is selected as a reference. It's paper class 1, 150 lines per inch. And the green area is the area my TVI should be. So I can see with the green dots, oh, everything's okay, perfect. I'm within the ISO standard. If I want to change the ISO standard, I can do it in the settings on the lower right side. And the bar is always on the right position. It's in the printing curve setup. And there you see I have all the tolerances. We are still supporting the old ISO tolerances, for example, 2007, because many customers are still working in accordance to FOCRA 39, and so we still have the old standards as well as the new standards for sure inside the instrument. And also the PSO, because it differs also a little bit from ISO and the FM screenings and newspaper. So everything is inside. Going back, just take another measurement to show you that not everything is perfect. And here you can see there are some dots that are red marked, so that means these three values are outside the tolerance range. So that is a quick measurement of a step wedge. You could do it for all four colors, and then you can immediately see if your TVI in the print is okay or not. Beside the CMYK print curve, we also support for sure the SCTV, spot color tone value. That was a new ISO standard. I think it was 2 years ago now, or even maybe 3 years already. We have been the first one who have integrated that. And this is also one of our, let's say, important points that we check what's going on the market. And if there is something that makes sense, we implement it into our instrument with new functions, new firmware updates, and provide it to our users. So I don't want to go too much into the densitometric part. So as you can see, we're crossing the border to the CIE, and here I can choose the LAB functions. Choosing the LAB functions, for example, I can measure LAB and density at the same time. So this is quite nice because I get all the values at a glance in the display. If you prefer to work with LAB and density separately, we have also integrated some nice features like shortcuts. So I don't like to go to the menu and open it and go back. So what we do is we have a nice feature. We press the red and the up or the down button, and I'm back on the densitometric side. And I can do the same. I'm going to the colorimetric side. So you can switch between your favorite function in densitometry and colorimetry by just pressing 2 buttons at the same time. So let's go to LAB, just the standard LAB function. In the LAB function, we usually do a calibration. So we put the instrument on the white standard. Always, if you don't know who has used the instrument before, the instrument will tell you, please use the white tile, press the start button, and the calibration will be done. And you can use the instrument immediately. So in the instrument, we also have color libraries. So on the right side, you can see there is the color books in the library. And here we have all these ISO, CRPC standards, Gracol, SWAP, own color standards, and spot colors, whatever you like. It is possible to measure your colors into the software. You can see here on the right side and the left side, there are some patches and some references. And you usually also can import values from other sources. For example, CXF3 import is possible. We also provide connectivity to Pantone Live, and from Pantone Live, it's possible to download color books into the instrument. So in case you would like to work with Pantone colors. So these color books can be used for the jobs, so that you say, I would like to ask my instrument to search automatically for the right color out of a color book. So let's take, maybe I take a spot color set. This is a color set with about 100 colors. And if you take a reading in the delta mode, then it will check what is the closest match, and it will give you the number of the color, and it will show you what is the delta E. So this is a typical LAB delta E comparing measurement. Now the question is, if my delta E is too high, what to do? That's what's the press operator asking usually. So the only thing I can do is increase or decrease the density. So can you help me, please? Therefore, we have another function which is called ink check. So with ink check, it is possible to get a recommendation of what to do. The instrument internally is doing an LAV measurement, and to do the right calculation, it will ask you, please measure the paper white, because the paper white has some influence on the appearance of the ink, if it's transparent ink, if it's a low density ink. So we have to measure the paper before we take a reading. And now I'm demonstrating that, not with the spot color set, but with a color sample. So I turn off the automatic search, and I'm measuring a color inside on the patch. For example, I'm taking the yellow. I'm taking the yellow 90% as a reference, and I'm simulating now more ink with the 100%. So the instrument will tell me you should decrease the density about 16 points or 13%. We're showing the 13% because some presses you can enter percentage value to control the ink. And then your delta E will come down from 7.5 to 0.4. So you can get perfect if you just follow the recommendation, reduce your density about 16 points, and your delta E will come down to 0.4. Behind the values, you can see these are the densities that are belonging to the delta E's. In the other direction, if I go for less ink, the instrument will tell you, oh, you have to increase the ink about 18 points. So 20% more ink will make your delta E come down from 10 to 0.6. So the recommendation is like a GPS system. It will guide you where to go to get to the target, to the destination as fast as possible. And this for sure is not only working with CMYK colors, it's also working for spot colors. Beside the ink check, then we have again an automatic function. And this G7 function is a very nice feature. We have developed it with the ID Lines G7 expert together. So we were asking them, what do you need? What do you have to analyze? What do you have to measure? And what's important for you? So we got the input, and we put everything together inside the instrument. And again, here we have the option to select in the G7 setup different step wedges. So we are supporting some step wedges. Some more will be added in soon. Then we have the different standards. So for example, the CRPC 1 to 7 characterized reference printing conditions. And I'm using a glossy coated paper. This is CRPC 6. We also have crack hole and swap. And so I'm selecting this target value and going back. And I'm using one of these nice strips we support. It's having all the patches included that is necessary for a G7 analysis. And so you just align the instrument on the bar. You start in front of the first patch, press the button, you scan, and you see it's very fast. You release the button at the end, and then you get all values directly in one display. So we are evaluating the primary colors, CMY, the delta E, 2000. You can see we are using automatically the right delta E functionality formula, and we also are using the right M condition. So the instrument is setting up automatically to avoid any wrong settings. Then we are comparing the black, its intolerance range, the secondary colors also, the paper white is okay. Then we have the weighted delta L for the CMY patches. All are good, average and maximum. And then we have the weighted delta C for CMY, the average and the maximum. and the weighted delta L for the K patches. It's all good, except the weighted delta C for the CMY should be 1.5, so the average value is a little bit high, and we are out of range. In case we are out of range, we can use the instrument now in spot mode. That means let's check just by a single measurement, what can we do maybe better. If we measure a primary color, then we again get the recommendation, okay, the delta E is 1.39, it's very good already, but if we reduce the ink, then we can come down to 0.8. If you go to the gray balance patches, so for example, the HR CMY, then we get recommendations what to do to get a better gray balance. So cyan is okay, magenta a little bit less, yellow a little bit less, and that would be perfect. So there are a lot of options just by scan and double check by spot color, by spot measurements, how good your results are and what to do. You see, mostly it's quite good. And we do the calculations then. Delta E 2.3, we can come down to 0.5 by increasing the density a little bit. So these automatic functions are helping the users, saving a lot of time. And there's a lot of self-confidence then if you get the values and you see you are in range. And so these are very helpful tools in our opinion. And as I mentioned before, we developed it together with the G7 experts. By the way, I think that was the function we have received the Intertech Technology Award in 2018, because it is providing a lot of helpful functions to the users. So let's go to another standard, or let's do from G7, from the US, we go to ISO to international. So we have the ISO check, again a scan function that will help the user saving a lot of time. The same procedure here, you can set the standard, you can set the control strip you want to measure. So we have all these ISO standards, 2007, 2013, white backing, black backing, PSO. So all standards are available, you just have to choose yours. And then we have another control strip, it's the PSO checker. It's just a very short one because we have less patches necessary for the ISO standard. Oops, sometimes I'm too fast. Okay, I make a scan. And again, I get all the values. You see in terms of ISO, it's okay. G7 was not so perfect because G7 is focusing more on the gray balance and ISO just on the TVIs. So we are checking the paper white, delta A, LAB is okay. We have the primary colors, delta E for CMYK is less than 5, it's okay. The TVI for the 80% and the 40%, it's nice. And also the mid-tone spread is in this tolerance range below 5%.
Albin, we're having a little trouble hearing you now. Albin? Sorry about this, everyone. Albin seems to be having some technical difficulty, so we'll just give him a second here to connect back in. I hope everyone is enjoying the webinar so far. I know Albin does a great job, and actually there are a ton of questions that came in, so we might go straight to questions. I also have Jinkai logged in with me, and he'll be able to answer some of the technical questions, which I think while Albin's doing that, he seems to be, working with things, trying to get things back. But Jinkai, are you here with me?
Yes, I am.
Oh, great. Okay, well, we will switch to questions for just a few minutes as Albin is working with his technical difficulties. So the first question that we have is, let's see, why don't you use the smaller aperture size as standard? Is there a difference in terms of measurement?
Well, so it really depends on what kind of work you do, and in other words, the resolution of your artwork. For some applications such as packaging, they don't have the luxury to put a full color bar on the press sheet. Then they would just usually put the spot color patch in the glue flap, and which are usually pretty small. Then it's a great idea to switch over to the 1.5 millimeter aperture. But again, the smaller aperture, the less sampling area you get into the the measurement and calculation. So if your resolution of the artwork is not not very high, and it depends on where you place your device aperture and measure, you might get some very slight fluctuation in terms of the either the LEB value or the density value. But if your artwork is very high resolution, you shouldn't be seeing any big difference.
Great. And then the next question is, can you scan a color cert target?
A color cert target. Well, I don't have lots of experience with the color cert target, but on the SpectroDens premium model, we do have a scan tool, which basically allow the users to scan a custom color bar. And since right now there's a lot of third-party software that connects to Teshcon SpectroDens, a lot of users, they actually use the scan function to feed the data into any third-party software for further analysis or calculation. So again, I have to see what the color cert color bar looks like, and then decide how we should use the SpectroDens.
Good. The next question that came in is, what size aperture do you recommend for offset printing at a high line screen frequency? And then he says, my SpectroDens currently uses a 3 millimeter aperture, and we use 300 LPI, and that is not a typo.
Yeah, so well, seems like the resolution is fine, so you can use either 3 millimeter or the 1.5 millimeter. Again, if your current workflow has a color bar that is large enough for the 3 millimeter aperture, I will still recommend you keep using the 3. That's because you get more you get more averaging in the data, since you are measuring a bigger area. So if there's any print defects on the press sheet, you are less impact if you are using a 1.5 millimeter aperture.
Great. And the next question, what is the new reference? We need some kind of accessory to make the measurement, for example, check density and later use for check a color.
Okay. Well, if I understand the question correctly, in North America, a lot of people using G7 as the the spec they run on press, so they will usually do a fingerprinting on the press, make sure they are achieving the G7 spec values, and then write down the target density, the TVI, so information like that, and then use that as the baseline when they continue to run the jobs to comply with the G7. But in Europe and some other parts of the world, they use ISO. So ISO, the 12647 will be the baseline for those customers.
Thanks for that, Jinkai. And the next question. Where do I find recommendations for relations between SpectroDens aperture and patch reference screen ruling? Yeah,
so I believe the ISO published a table that correlates the aperture size with the resolution, and I will have to dig into my files and then send that to you. So please reach out to us, and then so we can reply with you the table information.
Alison, can you hear me again?
Yes. Yes, we can hear you now, Alvin.
Okay. Welcome back, Alvin.
Yes, hello. Sorry for that. It seems like too many people in Germany are at the home office and streaming Netflix right now. So it's too much traffic.
Hopefully they're watching something good. So
yes, sure.
Right,
US movies.
All right, I will pass over back to Alvin.
Sorry for that. Yes, thank you very much. Okay. So I maybe continue with just the demonstration to finish that part. We did the ISO check, and finally I'm not using the video right now because I can imagine you know now how to use the device. So I'm using just the screenshot of the monitor, and what we can do, for example, is analyzing also media wedge. And media wedge, we are supporting the FOCRA media wedge as well as the Gracol or the ID Alliance Control Wedge 2013. So for example, if you just check CRPC6 and we are using the control wedge, maybe.
Hey, Alvin, sorry to interrupt you. Can you share the screen with us?
Oh, you need to send me the request?
Yes, hold on one second, Alvin.
Yeah, right. I forgot that. Okay, here we are. So now you should see me again.
Yes, yeah? We see you now.
Okay, good. So I'm selected media wedge. Oops, sorry. I'm selected media wedge, and in the media wedge, I can select certain references again. And I'm using CRPC6 for the Gracol, for the ID Alliance control wedge. And I do 3 scans, 3 lines. It is 3 times 28 patches. And it asked me 1 line after the other. And once I did that, I get the results on the screen. And I also could transfer it to the software. So, and on the screen, again, I can get the whole analysis about the delta E of the printing substrate, the primary colors, all patches, and the CMY patches. And this could be done by 3 scans for the FOCRA media wedge or the ID Alliance control wedge. So this also is a nice feature. And beside that, I have 2 more functions I would like to show you. That is also the answer to the questions: can we measure certain control strips? We can use the instrument as a, let's say, pure stupid scanning device. So we turn off the strip detection, so no checking of what will be measured. So we just take a reading of a certain color bar. Maybe I turn on the camera now again, so that you can see what happened. And now the instrument does not analyze anything. It's just measuring a wedge and detecting the information in the wedge. So take a measurement. That's it. So, oops, I was a little bit fast again. So press the button, scan, and I get the result. No. So, and now this information can be sent to any application that is supporting the instrument. That could be third-party software, but that could also be some own applications. We have in our software, we have the export module. And by the way, Chinkai Kian will show in April 28th a little bit about our software, what modules we are offering. It's a full quality control package. And we also have some nice new features, even Chinkai doesn't know right now. So you can see it here, and maybe until then we have something to have a preview. These are the Drupa news that will not happen this year, so maybe we can show you something at that time. So we can transfer values to any application. This could be, for example, an Excel sheet. I have prepared here something. So I have selected in my software, I want to transmit date, the time, the settings, and the LAB. And I'm using now the ECI control wedge that includes step wedges of CMYK in 10% steps. I take a measurement. This is something about 14 measurements. And I transfer the values. You can see now with a simple graph, you can see the lines of the CMY patches, the values, and so you could do your own analysis. By the way, we can measure up to 200 patches with a width of 6 millimeter. That means maximum scan length is 120 centimeters. Or just let me calculate, it is 47 inch. Yeah. So data transmission to applications with the universal scan functions in the instrument. And one nice feature also is the opacity. Sometimes you need to know how transparent is your paper. And I have prepared, let's say here, 2 different paper types. And they are not looking, they're looking a little bit different in brightness. But it's typical to say which one has more or less opacity. So what we usually do is we measure the sample over black. I'm using the recycled paper first of all, measure over black, and then we have to measure on a stack of 20 sheets. That means over white, and we got as a result the transparency or the opacity of that paper. So we have a 94 roughly for the recycled paper. Now we can do the bright paper. It is over black. Now I take the 20 sheets over white, and okay, 92. So it's a little bit difference between the recycling paper and the bright paper. Sometimes it's different. It's important to know, because if you have a very thin paper, you should take care that the backside print will not be seen through the front side print. And finally, that's the OBA check, where we do check the opacity, the optical brightness inside papers. I also have prepared some samples here. These are 3 papers. The sun is coming into my window right now. It's a nice evening, so maybe you still can see that. You can see that there is a little bit of color shade on these papers, but you cannot judge which one has a lot of optical brightness and which one less, except you turn on a UV lamp, and then you can immediately see, oh, there's just a little bit or nearly nothing. It's coming through the other paper in the back, and this is a very bright one, and this is also high, but not as much as this one. So this is important to know, because then your proofing system has to be matched to that paper. So in case you have a lot of optical brightness, you better go for FOCRA 51 instead of FOCRA 93. And if you have a look on that, then you can see Heaven 42, yeah, that's the bright paper or the paper with a lot of OBA, so you have to be careful. And what we do here with the instrument, we measure simultaneously M1 and M2. That means with a high amount of UV light and with UV cut. And we calculate the difference and get a classification. So this paper has no OBA. We have seen it, no reflection with the UV lamp. Then we have the Heaven 42, and that's for sure, it's a high amount of OBA. Then we have the other one, which also is high. And if we take our demo sheet again and take a measurement, then we can see it's a moderate optical brightener amount. So this is the only function which, in my opinion, makes sense to measure with two different illuminants at the same time, because otherwise normally the illuminants are, the measuring conditions are fixed. And like I mentioned before, if we go to ISO check again, if I'm using ISO paper class 1, that means it's 2013, then we have the M1 condition. And if I would go back to the old standard of 2007, and then the instrument automatically would switch to the legacy mode, the M0 condition. And that is also the same for the delta E formulas, depending on the standard you are using. For example, in media wedge, if you're using Focus 39, it's using the right delta E formula, depending on what you are selecting. So these are the most helpful functions we have inside the instrument. And beside that, for sure, you have some special settings about the delta E equations. And you see everything that should not be touched is blocked in the settings. You cannot change it because it's defined by the presetting by the ISO standard. So only if you use a function where it is allowed to change, like in LAB, so then you also could go to the settings and you could change your measuring conditions, M0, M1, M2. You can change the delta E formulas, and even so you can set up the K factors if you want to have a differentiated calculation for the CMC or 2000 formula. So that was it about the demonstration I wanted to bring to you, a little bit hands-on on how to use the instrument, a little bit more detailed about what's going on inside the instrument and what these functions are doing for you, what they can provide to you. And if you have any further questions now, I'm happy to answer.
Thank you so much, Albin, and I'm glad we were able to get logged back in.
Yes.
We do actually have a lot more questions, so we'll get right to it.
Okay.
The next question I have is, I have to use scan function on Mac OS X environment to send data to Excel. Is it available as a driver, or does it let me call mini SpectroConnect software for the Mac OS environment?
We have a Mac SDK, and we have also software on the market that is running on Mac and supporting SpectroDens. We ourselves at the moment do not have a solution. We are thinking about maybe having a small application where you get the values to the PC, or let's say Mac, so that you are able to get the values on your computer and you can work with that. But right now we don't have a solution for that.
And the next question, where can I download color books?
Color books. SpectroConnect, if you install the software, mostly of the color books, if you go to Open Color Library, will provide the most common standards, ISO standards. That means FOCRA, media wedge, ID Alliance, step wedges, ISO standard 2004-13, stuff like that, media standard PSO. If you need further standards, I don't know what exactly you're meaning. These international standards we are providing together with the SpectroConnect software. If you look for special color books, just let us know, and maybe we can answer the question by getting the information about which color books you're asking for.
Let's see. On G7 scan, could you add the tolerance numbers very small under the actual value? When something fails, it would be really nice to know what the tolerance actually is.
Yes, the display is limited, so if we add more information, then maybe it's difficult to see for, let's say, elder people who needs glass like me. What you always can do, you can go to the setup, and there you can find all the details. There is all the target values and all the tolerances. So if something should fail, just have a look into the settings of the device, and you can find all the values there. Maybe it's a little bit more comfortable than adding more information on the screen where it's full already with information.
Perfect. And just a side note on the color books, that we can also import CXF color books. Just a side note from Jinkai.
Yeah, right.
Thank you, Jinkai.
Right. I mentioned it, but it was maybe at that time when the connection was interrupted.
Yes. Next question is a battery-related question. Can you easily power the device off between uses, or does it only go to sleep? It seems older SpectroDens models did not have an option to power off.
We have a so-called power off. After 1 or 2 minutes, the instrument turns off. Not 100% completely, but the current which is used is so small that you nearly cannot measure it. But therefore, the instrument wakes up immediately. That means no waiting time if you want to start to measure again. And the power consumption during the power down mode is so low that you can leave the instrument for months in the shelf without using it, and the battery still is not empty.
And the next question, can the transferring of data from computer to machine be achieved, and can it save for future reference?
From the computer to the machine. You mean yes, I know what you're talking about. You would like to have some kind of jobs inside the instrument, and this is something we are working right now. It's maybe a little bit too early to talk about, but we want to make some customized settings, and so these are it's behind that icon here, and soon you will hear more about these possibilities.
And the next question, for the media wedge control strip, is the standard 12647-8 validation print integrated?
Yes, it is. Let me quickly check it, because I'm not using that very often. So let's say FOPRA 51. And if we go again to the settings, media wedge setup, and you can choose if you want to have it in accordance to the 2007 or the 2016. I think that's what you mean.
Yes.
You were talking about -8?
-8, yes.
Okay. Let me quickly check. I would need to double check. Maybe I can answer later. Because
yes. So, yep, Albin. One thing that I would like to let everyone know is we have the ability to email everyone, not only the webinar recording, but if you had a specific question that we, for whatever reason, couldn't answer or ran out of time, we will be emailing people individually to give them the answer to their question.
Yeah. And maybe on the screen now you can see what we are doing with the PSD, so the print standard digital. We do the media relative and PSD absolute side-by-side evaluation, but this is something Jinkai will talk about next week.
And let's see, the next question, when do you adjust white reference to absolute and when to relative?
This is a regional setting, more or less. Usually in Europe, if we go to a densitometric reading, in Europe we are using as as a white reference, we are using paper white. And if we set the instrument to auto, then it's taking care automatically. In Europe, we're also using normally polarization filter. So we turn it to auto, and the instrument for densitometric reading is using automatically then the European settings. That means ISO E for the density filter, polarizing filter turned on, white reference is paper. For the US standard, it's ISO T, it's non-polarized, and it's absolute white. So these are regional settings, I think by history, and absolute white for densitometric readings in the US.
Great. Let's see. While Grackle has a large presence in the US, Fogra is popular in Europe and has a very long history. What is your favorite method target for offset printing?
I have to be careful. We are supporting both. And this is also now, you see, you can get in the new ISO standard, you can work in accordance to both methods. You can go for TVI, it has advantage and disadvantage. You can go for G7, it also has advantage, and somebody told me it has disadvantage. I never have seen it yet. So yes, it's difficult to say. I'm a friend of G7. This is something I can say.
Okay. And the next question, can you please discuss how this unit would benefit your expanded gamut users?
Expanded gamut users, we also are quite having a look on that. Right now, I mean, on the colorimetric side, it's doing everything you need for expanded gamut. You have the LAB readings, and for CMYK, OGV, or whatever combinations you could do the LAB readings. And the question would be if we add something for the densitometric part. Let's say, do customers then work on the densitometric way, and they want to have here the 5th, 6th, and 7th color also as a density value? This is something we are discussing right now, and if we have some input from our users, what would be helpful for them, we are happy to get some feedback, because all the functions you have seen right now haven't been developed by ourselves, but mainly in cooperation with our users, with our customers. So because they know exactly what they need. We have nice ideas, but sometimes it doesn't match to the needs. So for every input we get from the market, we are very glad and grateful, and then we transfer it into new functions. So if you have some information for us, please provide it, and we have a look at it.
No, that's great, and actually we have a few comments coming in about that, which we can share. So that's really terrific. The next question: in the scanning mode, can you scan spot colors?
Yes, sure. We can measure. We can scan every colors. That doesn't matter if it's CMYK or spot. It depends on what functions you want to use. For densitometric readings, for example, the SCTV print curve is made for spot colors. The universal scan function can surely be used for spot colors, because it transfers the information you would like to transfer, LAB or XYZ or whatever.
And a short note from Jinkai back to the expanded gamut question, I think. And he says we can use SCTV to control TVI curves for expanded colors.
Right, yes, sure.
The next question: I have been able to upload, I think he's asking, can I upload my Pantone book onto the SpectroDens?
If you have it available as a CXF3 format, then we have a function called CXF3 import or CXF import. And if you have this file in a CXF format, then you can import it. Otherwise, we have the option with the software to get access to Pantone Live. For sure, that is is combined with some license fees, but then we can have access to Pantone Live, and then we can download to the software and also into the instrument.
And just a couple additional questions here. Can the SpectroDens be used to check variation to Pantone spot colors?
If you have a Pantone digital value inside the instrument, then it can easily be used also with automatic functions to show differences, yes.
And do you have standard Excel files already built that can be utilized to import different scanned data for record keeping?
Yes, many. Just let us know what you need and we have a look on our selection, and if there's something for you that's matching, we are happy to provide it free of charge, and you can modify it on your needs.
Great. And I think we have just one more question, and it is, when we measure a spot color in SCTV, can we show the density and the dot gain, not just the dot gain?
No, because it's a colorimetric calculation. So has nothing to do with densities. I mean, you can go back to a density mode and then check the density in a separate measurement. But during the scan, all values are colorimetric values. And so you will not get at the same time any density values.
Wonderful. Well, thank you so much, Albin, for that really fantastic presentation. And I do want to let all of the attendees know, as I said earlier, I will be sending out the recording. And also there are a lot of questions that were really will be answered on a more personal basis. So we will be emailing you one by one if you had a question related to a repair or you know, getting a calibration chart or something like that. Please know that we will be getting back to you. And thank you everyone for attending.
Thank you very
and
much.
Have a great rest.
The same to you. Stay well, keep safe, and yeah, hope to see or hear you soon again.
Yeah, same here. Bye-bye, everyone.
Thank you. Bye-bye.